In this video, you will listen to the sounds of space. Much of our universe is too distant for anyone to visit in person, but we can still explore it. Telescopes give us a chance to understand what objects in our universe are like in different types of light. By translating the inherently digital data in form of ones and zeros captured by telescopes in space into images, astronomers can create visual representations of what would be otherwise invisible to us. But what about experiencing these data with other senses, like hearing? Sonification is the process that translates data into sound. Since 2003, the black hole at the center of the PERSEUS galaxy cluster has been associated with sound. This is because astronomers discovered that pressure waves sent out by the black hole caused ripples in the cluster's hot gas that could be translated into a note, one that humans cannot hear some 57 octaves below middle C. Now a new sonification brings more notes to this black hole sound machine. This new sonification, that is the translation of astronomical data into sound, had been released by NASA for its Black Hole Week this year. The sound waves were extracted in radial directions, that is, outwards from the center. The signals were then resynthesized into the range of human hearing by scaling them upward by 57 and 58 octaves above their true pitch. Another way to put this is that they are being heard 144 quadrillion and 288 quadrillion times higher than their original frequency. By the way, a quadrillion is 1,000,000,000,000,000,000,000,000. In addition to the PERSEUS galaxy cluster, a new sonification of another famous black hole was released. Studied by scientists for decades, the black hole in Messiah 87 or M87 gained celebrity status in science after the first release from the Event Horizon Telescope or EHT project in 2019. This new sonification does not feature the EHT data, but rather looks at data from other telescopes that observed M87 on much wider scales at roughly the same time. The image in visual form contains three panels that are from top to bottom: X-rays from Chandra, optical light from NASA's Hubble Space Telescope, and radio waves from the Atacama Large Millimeter Array in Chile. The brightest region on the left of the image is where the black hole is found, and the structure to the upper right is a jet produced by the black hole. The jet is produced by material falling onto the black hole. The sonification scans across the three-tiered image from left to right, with each wavelength mapped to a different range of audible tones. Radio waves are mapped to the lowest tones, optical data to medium tones, and X-rays detected by Chandra to the highest tones. The brightest part of the image corresponds to the loudest portion of the sonification, which is where astronomers find the 6.5 billion solar mass black hole that EHT imaged. Now let's listen to the center of our very own Milky Way galaxy. The translation begins on the left side of the image and moves to the right, with the sounds representing the position and brightness of the sources. The light of the objects located towards the top of the image is heard at higher pitches, while the intensity of the light controls the volume. You can listen to the sounds of many more space objects on the website chandra.si.edu and the YouTube channel of Chandra X-ray Observatory.